All right, today we're going to talk about the ocean floor and different features of the ocean floor. So the ocean floor comprises about 71% of the surface of the earth. We talked about that at the beginning. So what that means is that almost 3/4 of the world is actually under the ocean. But what's kind of cool about that is that most people haven't ever seen it and won't ever see it. So the only way to study the ocean floor is either in a submersible, so taking some kind of submarine down, or the use of sonar. Which we talked about a little bit in our last lesson. So one of the options is to take a submersible, and humans have been building better and better and better submarines for a long time, but we wanted to try to build a submersible that could be self-powered and could travel all the way down to the deepest part of the ocean. So many of you probably know that the deepest part of the ocean is just off the coast of Japan. It's called the Mariana Trench, and the Mariana Trench is has a spot at the bottom, so the very deepest point of it is called the Challenger Deep. And in the 1950s, there were a group of scientists who wanted to go down to the bottom of the ocean, and so they built this, it's called a basket, which is this pressure sphere is what they called it. Its official name was Trieste. It was designed by Swiss scientists and explorers, and it was made in Italy. So it's actually named for a town in Italy. That's where the name Trieste comes from. And it was the first submersible to reach the bottom of the Challenger Deep. And it got there in the late 1950s. And was the first expedition to reach and the only expedition to reach Challenger Deep for a very long time. In 2012, there was another expedition led by James Cameron and sponsored by National Geographic, in which he went on a solo mission down to the bottom of the Mariana Trench, and he was only the second person to reach that far. And so that just recently happened in 2012. Still to this day, fewer people have been to the bottom of the Mariana Trench than have been to the moon. So the ocean is in some ways less explored than parts of space, which I think is pretty neat. Because we can't have somebody travel in a submersible to every part of the ocean floor, one of the places or ways that we've learned a lot about it is to use sonar, which we talked about last time. So if you remember, sonar could just, a ship or a submarine can go back and forth, bouncing sound off the bottom of the ocean floor, waiting for it to reflect. And then based on the time that it takes, it can determine which parts of the ocean are closer to the ship and which parts are farther away. The closer parts are marked as more elevated, and the farther away parts are marked as deeper parts of the ocean. And so from that, we can get a map that looks like this. This is what we would call a bathymetric map of the ocean floor. And so the bathymetric, anytime you see bath, you should be thinking, it's usually used to refer to like the bottom of the ocean, okay? And metry is just, a measure of that. So this just basically measures how deep is the ocean in this point, okay? So how deep is the water is the way you could think of this. Looking at this, lighter regions of this map are going to be higher, okay? So if you look right off the coast, so like if you're swimming here and you go to the beach in Carolina, or let's say you go to the beach up in north, in Canada or the northern United States, you're going to be hanging out up here, okay? Then this is going to be a little bit shallower. Let's say you go down here and you're going to go to Florida, like the Florida Keys or any of these islands down here. If you've ever been there, there's this kind of bizarre phenomenon where you can walk way, way, way out into the ocean. Much farther than you would think you would be able to, because the ocean here slopes down very gradually. It's very shallow. So these areas are going to be marked with lighter colors. If you come here to, like the middle of the ocean floor, or if you come over here even off the coast of Japan, you can see here where the Mariana Trench is. The Mariana Trench is this very dark blue line here, and that's the deepest part of the ocean. So the darker the colors are, basically the deeper it is, the lighter the regions are, the lighter it's going to be. So you can already start to see that the ocean has different recognizable features, okay? You can kind of see some, like some peaks here. You can see sort of trenches over here. And then we can see big flat spaces like this over here in the Pacific Ocean. And we're going to talk about each of those features. So just like on land above the ocean, we have features that can be called landforms, right? So you could have canyons, mountains, plateaus, riverbeds, lakes. You know, we have all these different features that we can see, and they have different shapes, right? If you go to arches and you see the arches that are there, you're going to see all these different shapes, right? Visit the Grand Canyon, you can see those things. Come to Colorado, you see the mountains, right? So Earth does not look like one kind of uniform area. And people mistakenly think that the ocean floor does look like one uniform area. That's not at all the case. So we have certain features in the ocean floor. Those features are the continental shelves, abyssal plains, mid-ocean ridges, seamounts, and deep sea trenches. We're going to talk about each one of these in more detail, so I'm not really going to explain them individually at the moment. We're going to start with continental shelves. So the continent does not just drop off when it gets to the water, right? It has to slope out gradually. And as it does that, when that part that's underwater but is still sloping away gradually is going to get the name the continental shelf. Now, the continental shelf can vary in width. So if you are to go to the beach and you went to just even the different coasts of the United States, if you came over here to California, the continental shelf, you might actually even be able to see it in this picture. The continental shelf is much shorter than it is if you were to visit over here in North Carolina. So if you come over here, you can kind of see the shallow portion is all the way over here. So depending on where you are, the continental shelf varies. So in California, we would measure that continental shelf at about 20 miles, while in Carolina, north or south, it goes in both, you would measure it at about 80 miles wide. So it's almost 4 times as wide of a continental shelf in Carolina as it is in California. And so the continental shelf, if we were to draw this, so the continental shelf would look like a gentle slope. So if we get here to the ocean, the continental shelf, oh, sorry, I'm trying to grab my marker here. So the continental shelf would look like this. It would slope out gradually, and then we'd get a much steeper slope all of a sudden, okay? Make that a little wider. So it would go out gradually, and then all of a sudden it would get much steeper. So this would be what we would call the shelf. Okay, so this is the first part that we talked about. You could either talk about it as, you know, we usually would call this the shelf. This would be called the slope. So the continental slope is much steeper. And so with the continental slope, where we would notice it, okay, and it's going to happen in different places, but what we would be looking for is this basically a little bit more sudden drop off to where it becomes steeper. Now, because this is steep, as waves kind of come back in to the ocean, as waves come back into the ocean and this water is moving, a lot of dirt and sediment and debris is going to get washed over this little ridge line here. And as it does, it will kind of pile up down here at the bottom. And so we'll get, I'm in trouble drawing today apparently. So we'll get this pile of stuff that kind of collects here at the bottom and slopes up. And so this little area where the sediment collects, okay, or mud or whatever you want to call it, is going to wash down here. This would be called the continental rise. And the reason we call it the rise, at least the way that I remember it, is because as sort of sediment and mud and sludge collect here, it's going to rise up, so it's going to get taller, okay? So you have your shelf, which is the gentle slope, or the gentle kind of approach here. And then you have your continental slope, which is the much steeper section. And then you have your rise, which is that collection of material that kind of washes over the continental slope. One other interesting feature that I can't really draw for you because I'm not that great at drawing in 3D, but I am going to show you on a map, is this submarine canyon. So how this submarine canyon is formed is, let's just map out the parts that I was just explaining to you. So here, this sort of area, right, we have the continental shelf. So the continental shelf would be this area here, all right? And then we have our continental slope, which would be this area here. It's a little bit steeper. Then we have our continental rise, which would be this area here. That's where all the debris that's washing over this is collecting. And then running through all of that, we have this feature called a submarine canyon. So a submarine canyon is where this actually gets washed out and we get a really deep channel that actually runs through the continental shelf, slope, and rise. And where this comes from is when a river actually washes through into the ocean, and it slowly, just like it would do on land, it cuts basically a canyon through this area. So you can also have underwater canyons carved by rivers, not just above water canyons. These canyons are a little bit more rare because the water has to flow in a certain way in which to cause them, but it does happen from time to time. After this, so we have our continental shelf, our slope, and our rise. We're going to come out here to another feature, and this feature is the abyssal plain. Okay, so the abyssal plain is exactly what it sounds like, as in the plain is a flat spot in the ocean. Okay, so just like we have plains above land, or on land that are large flat pieces, usually covered with grasses. In the ocean, we have large flat spaces as well, and that are called plains. All right, so moving on. Talking a little bit more about those abyssal plains. The abyssal plains are kind of cool because they're the flattest things that we have on Earth. So if you imagine, if you've ever driven through Kansas or Nebraska, especially if you've been in Kansas or Nebraska, driving there for several hours, it may feel like the flattest place on Earth, right? So boring. You just drive in a straight line, right? And there are barely any hills or anything. Imagine the ocean floor. There are parts of the ocean that are almost perfectly flat. And they are large, huge expanses. We can't even really imagine how large they are. They cover about half of Earth's surface, and they're found anywhere from 3 kilometers to 6 kilometers deep in the ocean. To give you an idea, that's 1 to 3.5 miles deep. If you were to take that last one, if you think about running a 5K is about 3 miles, right? So if you were to run a 5K starting on the surface of the ocean and you could run straight down, there are places where you would run basically the whole 5K just to get to the bottom of the water. So I think that's kind of neat to think about. That deep into the ocean, sunlight can't reach, so it's going to be pretty much completely dark. Only 1% of the sun's light gets that deep into the ocean. So it's essentially complete darkness. And the pressure, this is why you wouldn't want to run a 5K to the bottom of the ocean. The pressure is 300 times greater than the atmospheric pressure that we experience here on Earth, like at sea level. So imagine, if you've ever swum to the bottom of a swimming pool, you can feel kind of the pressure building up as you're on your ears as you swim down. Imagine 300 times that atmospheric pressure. It would be enough to just to crush you. So you wouldn't want to be down at the bottom of the Mariana Trench just yourself. For example, when they built that submersible, if you remember that picture of the Triste I showed you at the beginning, or if you want to go back and look at it now, you'll notice it's a perfect sphere. And that's because there would be so much pressure pushing down on it at any one point in time that it has to be a particular shape to help balance out all that pressure and to distribute it over a larger surface. But there are crazily enough, organisms that can live under that kind of pressure in the abyssal plain. So just because humans aren't suited to live down there doesn't mean that nothing is suited to live down there. So we do find life on those places, even though they seem pretty barren. This is just another bathymetric map of the ocean. And what I wanted to show you here is something that we call the mid-ocean ridge. So just to kind of orient you to where we are, this is the coast of the United States, so North America, South America, and then this over here would be Africa, and we can imagine that up here is Europe. Running through here, we have what we would call the mid-ocean ridge. And what this is it's actually two ridges of mountains. Let's see if I can draw in here. So we have actually two, oh, I keep forgetting to actually click my pencil. Okay, so we have along here two ridges of mountains which run here, and they're running parallel to each other. So there's a second ridge here. And then in between them, we have this kind of canyon, okay, which we're gonna call a rift valley. So we're gonna look at these three features in more detail, but I just kind of want to explain to you what they look like now. So we have these two parallel peaks, and then in the middle, you can see this deeper area. All right, we're gonna spend some time talking about that now. So the mid-ocean ridge, it wasn't until the 1950s, so around that same kind of period of ocean exploration that we were talking about earlier with Triste, is oceanographers actually realized that the longest mountain chain on Earth is hiding under the ocean. So that's what you were just looking at here, is this is actually the longest mountain chain on Earth. So if you think about other mountain chains, like for example, the Rocky Mountains would be over here. So the Rocky Mountains would probably only be this like first section, right? Or if you think about the Andes Mountains, which is the longest mountain range that is on land in the world, it would just be like this bottom half portion, right? But this whole connecting portion of all these mountains, and it goes a little bit deeper than what I've shown here. Maybe I'll take you back and show you the map really quickly. Okay, so looking here, you can actually see this mid-ocean ridge and see how long it is. So it starts up here and it travels all the way down through here. So this is the largest mountain range on Earth, and it's under water. We didn't realize that it was even there until the 1950s. So this is what we call, what we mean when we say the mid-ocean ridge. The mid-ocean ridge is, so the whole mid-oceanic ridge extends through every mountain, through every ocean basin, okay? So you can see the one that I just highlighted is the Mid-Atlantic ridge, but the entire thing, right, you can see that there are other ridges expanding through these other basins, okay? So this one is what we call the Mid-Atlantic ridge. That's kind of the biggest, most talked about one, and then there are other ridges as well. And in between the two rows of peaks, we have a rift valley. The rift valley, scientists suspect, comes from ocean basins that are spreading apart. So basically the rift valleys rupture and they get pushed apart by new magma, which flows up in between those two mountains. And as that new magma kind of pushes out, it causes the rift valley to widen as the mountains expand away from each other. So here's just another picture of that Mid-Atlantic ridge. So this is, you can see it winding all the way down through here. And then if you look very carefully, you can see this deep line running through the middle. That would be the Rift Valley, okay? If you want to look at these mountain ranges, you can see that the mountain range corresponds to what we would call the plates. When we talk about plate tectonics, right? The world is not made of one solid ball. It's made of these plates that kind of travel around and they bump into each other, right? We're going to talk about this more when we talk about geology in our next unit. But for right now, I just wanted to show you where the plate boundaries are. And you can see that the mountain ridges actually really nicely follow those plate boundaries. So if you kind of look at this and hold it in your mind, and then we'll go to the other picture. You can see that these mountain ranges here, right, are following kind of that plate boundary. And if you look over here at where some of these ridges are, you can see that there's a plate boundary kind of coming out this way and down here that very nicely mirrors these mountains that are coming out here and down this way. So the reason that scientists think these rift valleys are spreading is because along plate boundaries, we can get what we call divergence, which is where the plates are moving apart from each other. And when the plates are moving apart from each other, they can't just leave empty space behind, kind of in the crack. So what happens is magma wells up to fill that crack as the plates move away from each other. So if we imagine that these are moving away from each other, so moving away from each other in this way, then we would realize that this would spread and become a little bit wider, right? And new magma, or what's going to become new rock, new ocean floor, is going to flow through there. Okay. So that gives you an idea of what these like long ranges of mountain ridges and rift valleys look like. Seamounts would be underwater volcanoes. So a lot of 90% of Earth's volcanoes, actually, so most of them are under the ocean. Okay, only a small fraction of them are tall enough to rise up above the water. And when they do, they form islands. So if you've ever been to Hawaii or seen pictures of Hawaii, Hawaii is an example of a cluster of islands that are all volcanoes that got so tall that they rose above the island of the water, and they formed islands. If a volcano is completely submerged underwater, though, we call it a seamount. So if we take that picture of Hawaii and we actually look at Hawaii here. So here are the Hawaiian Islands, right? And we call them islands because even though they are volcanoes, they're all pushing up above the surface of the water. Now, what's really cool is if you go to the region of Hawaii on a map and you actually make it a bathymetric map, which I'm going to do here, you can see that actually Hawaii is just a small part of this whole chain of volcanoes. So all along here, following this plate boundary here, you can see that Hawaii is just one tiny little, like section, one segment. So here are the Hawaiian Islands here. Oh, I keep making them disappear. So here are the Hawaiian Islands here, okay? This whole chain here is all also seamounts. And you can see there are various other seamounts. So it's part of a larger chain called the Emperor Seamount Chain. And so we tend to see that volcanoes cluster along plate boundaries like this because it's an easy place for magma to move up to the surface and to create a volcano. So I just show you that to make the point that for every above water volcano that you see, right, there are 9 other underwater volcanoes that cannot be seen. Deep ocean trenches. So deep ocean trenches, we talked about a little bit already. The Marianas Trenches, or the Mariana Trench is the deepest ocean trench, but there are other ocean trenches in the world. So it's not the only one, but they're mainly found next to continental coasts or island arcs. So if you actually look back here, you can see some ridges and then some trenches. This trench right here is called the Aleutian Trench. So that's a fairly large trench, but you can see right along above it, there's a ridge. So ridges and trenches tend to go together because they come from where plates are converging. So one plate is pushing into another plate, and what happens is part of the crust subducts and goes underneath of the trench, while the other one pushes up over the top. So we can get both a ridge and a trench in a similar location. So the deepest place in the ocean is the bottom of the Mariana Trench, called the Tallinder Deep. We already talked about this, but I want to tell you and kind of give you an idea of just how deep it is. So it's 35,814 feet deep. And you think, oh, okay, well, that sounds really deep, right? But just how deep is that? So this is a fun game I like to play called Would It Fit in the Mariana Trench? So let's see, we're going to just ask a question about what could we fit in the Mariana Trench if we were going to pack for our vacation. Okay, so what could we pack in the Mariana Trench? Well, if you take the world's tallest building, which is about 2,723 feet. If you were to take this building and you were to try to pack it in the Mariana Trench, you would fill up that trench to, well, let's see, about here. If you were to take the city of, like, so from sea level to the city of Denver, which is a mile, or if you think about running or walking a mile, if you were to start at the bottom of the Mariana Trench and you were to run a mile, you would end up about here, okay? If you were to take one of our mountains in Colorado, or you could take the Matterhorn, it's about the same height, but we have lots of 14ers, right? 14,000 foot peaks in Colorado. And you were to drop the whole 14er into the Mariana Trench, it would come out to about here. If you were to take the tallest mountain on land and you were to take Mount Everest and drop it into the Mariana Trench, now it wouldn't fit sideways, right? But if you were to take something that tall and drop it in, it would still be completely covered. If you've ever flown on an airplane and you get to your cruising altitude, which you usually know that you're there because you can, they'll tell you that you can take off your seatbelt, right? And so when you do that, they'll tell you can take off your seatbelt. You're going to be up here at this height. When you're at that height, it's going to tell you that you are, right, you'd be about here. So when you get to that cruising altitude, so think about when you take off in a plane, think about how tiny all the cities look and all the people look, and you know how you're above the clouds and all of that. If you had taken off from the bottom of the Challenger Deep and flown to your cruising altitude, you would still be in the Mariana Trench. You wouldn't be in there by very much anymore, just about 1,000 feet, but you still wouldn't have flown out, which to me is pretty incredible. So then the question is, what kinds of things have been down in the Mariana Trench? If you think about this, not necessarily all these things are in the Mariana Trench, but to give you some ideas, a sperm whale can dive really deep. And so their average depth is about 3,000 feet, but we've placed them about as deep as 9,000 feet into the water. So a sperm whale could probably dive somewhere anywhere from this deep to this deep into the Mariana Trench. The Titanic sank in very deep water, and so the final resting depth of the Titanic was about 12,000 feet, so it'd be about here. A snailfish is one of the deepest living organisms that we were able to discover. It lives at about 25,000 feet under. And then prior to the the deepest thing, James Cameron has since changed this record, but the deepest thing that had gone into the Mariana Trench was a robot operated vehicle, an ROV, right? And so, a remote operated vehicle, sorry. So it was, it had gotten down to just about the bottom of the Challenger Deep, but James Cameron was actually able to go deeper than this. So now a human has actually been deeper than a remote vehicle. All right. So let me make my markings disappear. All right. That's going to be all that we are going to do for today. So that covers all of the features of the ocean floor. We will talk about some things that are found on the ocean floor, as well as classifying the different animals in another lecture. So have a great day, and I will hopefully see you guys all soon this week.